we're going to start to discuss linear functions. And linear functions, as you might expect, are functions where the graph is a straight line. The definition of them is any function that can be written in the form f of x equals something times x plus something else, or, as we more commonly write it, y equals mx plus c. Now, just because it can be written in that form doesn't mean it always will be written in that form, because we often, of course, have it like this: ax plus by plus c equal to 0. So we often have it with everything on one side equal to 0 rather than isolating the y on its own. And we've seen that before. In any case, when it's written like this, with the output equal to a formula for the input, then the coefficient of x is our slope, and the constant is the y-intercept of the graph. And what does y-intercept mean? It means the value of y where it cuts the y-axis. If you want to plot a graph, you either need to know two couples, 2 points, xy pairs that are on the function, or the slope of the line and 1 point. So you know, if it's written like this, we know 1 point, the y-intercept, and we can use rise over run to plot the slope. Generally, I find it's easier to do it by the 2 points, because people can get a bit confused about rise over run and whether it's a positive or a negative slope, but either way, you can plot it if you have either of those pieces of information. So if we're asked to plot the graph of a linear function like this, we can see it's not in the form y equals mx plus c. It's kind of a mess with some of the things on one side and some of the things on the other side. And the easiest way to do this would be to find both the x-intercept, where it crosses the x-axis, and the y-intercept. You can find any points on this graph by subbing in any value you like for x and finding the matching y value, or any value for y and finding the matching x value. So the reason we might find the x-intercept is because we can just sub in y equals 0, and the y-intercept because we can just sub in x equals 0. The x-intercept means where it crosses the x-axis. So let's do our calculations for that, and then we'll do the plotting. So when y is equal to 0, we get 3x minus 0, 2 by 0 is 0, is equal to 2. So x is equal to 2/3. And our x-intercept is going to be the point 2/3, comma 0. 2/3 is the value for x, 0 is the value for y. And when x is equal to 0, or y-intercept, we sub in 0 for x, and we get 3 by 0 is 0, minus 2y is equal to 2, and so y is equal to negative 1. Y is equal to minus 1, and our y-intercept is at the point 0, minus 1. So we have 2 points. All we need to do is plot those and join them together. So we'll draw our axes, and we need to go over at least as far as 2/3 in the x direction, and go up a little bit more. We need to go down as far as minus 1 in the y direction. So just give yourself plenty of space, well, depending on how much space you have in your notes after you've done your calculations. So my y-axis is vertical, my x-axis is horizontal. Mark in the points 1, 2, minus 1, minus 2. You'll notice you don't have to use the same scale for the y-axis as you do for the x-axis, but you do have to not do what I just did there. You do have to do the same above and below the line. So if I'm using 3 boxes for y down here, I need to use 3 boxes for y up here. And we'll mark in our points. So the y point first, minus 1. There's my y-intercept. I don't have to label it, but I just want to make it clear because it's the first time we're doing it. And my x-intercept then, 2/3. 2/3, 0. And then all I need to do is draw a straight line going through those 2 points. And I don't stop at the points because lines are infinite. They go on forever in each direction. So I draw my line going straight through there. And it's good practice to label your function once you've drawn the graph. So this is the graph of 3x minus 2y equal to 2. So I've just done a label over it like that. Okay, and that's how you plot a linear function. One way to do it anyway.